All right, so let's start. Here's what we're doing today. Questions about things, reminder about the homework, and then we're going to talk about Git, the revision control system, for the rest of the day. So first, are there questions about anything? One person right before class asked how to change the current directory in a Python session, which is something I've never showed you before. But there's a command os.chdr, which stands for change dir. So if you do that and give it a directory, it's kind of like cd on the command line. Homework is due as usual. Homework, I guess 5 is due on Friday. And grading of homework 4 is due on Friday. The grader Simon pointed out that everyone did homework 3 and graded homework 3. So not one of all 40 students in this class flaked out and either didn't do homework 3 or didn't do their grading of homework 3. So good. I'm glad. By the way, Simon, as you probably saw in a message, is not around for the next week and a half or two, since he had to go to South Africa to get a stamp on his visa. So just be lucky you don't have to fly to the opposite side of the world to get a stamp on your visa, because that's ridiculous. Okay, so there's that. And we'll start on today unless there are any questions before we get going. Okay, let's do it. So let's see. Some quick notes. I've been doing a lot of upgrades to SageMathCloud. It's like just the static web server, the Node.js, everything kind of between here and there is upgraded. The projects are now running Ubuntu 14.04 rather than Ubuntu 12.04. It's a new version of Sage. Every Python module in there is upgraded, except for the projects that are running at Google. I'm not going to upgrade those until I think tonight. I'm doing that a little bit more slowly. But all the ones that are running at UW are upgraded. If you want to know where a project's running, you type hostname in a terminal or in this little thing that says terminal command. And if it ends in DC0 or DC1, that means it's running at University of Washington. If it ends in DC2 or higher, that means it's running at some data center owned by Google. And it can change if your project is moved due to maintenance or other things. Okay, so we're going to do a tutorial, and it has a couple of different parts. The first part will be to make a basic Git repository and make it publicly available. Basically, we'll make a new open source project, and we'll go through all the steps to create it, make it available on GitHub. To do it with Bitbucket would be very similar, and that'll be the first step. And then after that, we're going to fork the repository, make changes there, basically do the workflow that's involved in an open source project. Okay. So instead of my completely random example, I'm going to make an example which will be based on implementing the Gaussian rationals, which was one of your homework problems. So we'll do that. Okay, so what I'm going to do, just to give you a quick overview, is I'm going to create a Git repository in a brand new SageMathCloud project. I'm going to put a file in there called gauss.sage. I'm going to edit it a little bit so it has some very, very, very minimal amount of functionality. Maybe it'll just do hello world, I don't know. We'll see in a minute. Then we will commit our changes to a local Git repository. Next, we will create an account on GitHub, and we will push our changes to a project on GitHub. And then we'll, for practice, pull it to a different location, make some changes, and push those back. And I'll also show you how to set up SSH keys in a project so you can push and pull to GitHub without having to type any passwords or anything. You just maybe have to type a passphrase to unlock your SSH keys. So I'll show you all those steps. Then after that, we will, as a different user, fork the project on GitHub, make a copy of it, make some changes, and then send a pull request. So you'll see how that workflow goes. And finally, after we do all that, or maybe as part of doing that, I'll show you how to work with branches with Git. Okay? So those are the steps that we'll go through. I don't think we'll be able to finish every one of these steps today, but we certainly will this week, no problem. And right after we do this, the next thing we're going to do is talk about the workflow for doing Sage development, which involves getting a Git repository with a certain branch, making changes to Sage, and then pushing those somewhere, okay? All right, so here we go. So first, I'm going to do this in a brand new SageMathCloud project so that there's some issues that come up when you're working with Git. For example, you have to create a file .gitconfig, which says what your name is, your email address is, etc., so that when you make commits, it lists who's making those commits. And also we'll want to set up SSH keys that link a project to something on GitHub. And since I have that stuff already set up in this project that I'm using here, I want to do things from scratch so you can see the whole process without several things that will trip you up kind of being skipped. Okay? Any questions? Right, let's do it. So what I'm going to do, let's see, I want to have it in 2 locations. Okay, I have the steps right here, and I'll make a new project over here. Okay, new project, demo of using Git in SageMathCloud for Math 480B. Okay, so I'm making a brand new project. I won't see it because I have these tags selected. Now here it is. No, that's somebody else's project. Where's my new? Oh, here it is. It's not at the top. So demo of using Git. So click there. It's now opening the project somewhere. And that should take 30 seconds. And it's faster than 30 seconds, apparently. Okay, so that was step 1. We made a new project. Now we're going to do these various other things that are listed. Okay, we're going to use the, we can do many of these steps either with a terminal or in the graphical environment. For example, any terminal command like git init that you might type, as long as it doesn't require interactive input from you, like it doesn't pop up an editor or something, you can actually just type it where it says terminal command in that box right there. All that happens when you type something in there is it just gets sent as a single command. As long as it takes at most 15 seconds to run, it will show you the output and work. Okay, so let's get going. So I'll click here, and I want to make a new directory called Gauss, which is where I'm going to put my code. And now I'm inside of the new directory Gauss that I just created. And now I'm going to do git init. So I'll type git init. And what that does is it creates a new Git repository inside of that directory. Remember we did this last time at the very end. Okay, and it says initialized empty Git repository. So that's done now. It looks exactly the same. However, if you click on this little toggle whether or not to show hidden files, you'll see that there's now a hidden directory .git. Before I didn't show you what's inside of that directory, but if I click there, you'll see that there's a whole bunch of subdirectories. This is kind of small. Let me zoom in some. So there's a whole bunch of subdirectories, objects, hooks, config, head, etc. These are, so Git is kind of like a database. In fact, it is basically a database, and these are the files in which it stores its data. It's a very compressed and deduplicated database, in that if you store the same data twice, it uses almost no extra space to do so. And it's also, in a sense, like a database, but with kind of a very weird model of doing queries. So you can't query it like a normal database, but still very useful for storing data. And by the way, conceptually, the way you should think of Git, it stores basically, it very efficiently stores a directory hierarchy, kind of. Like you think of it as each snapshot's like the complete collection of files at a given point in time. So it very efficiently stores those things, and it refers to them by SHA-1 hash of the content. So if anything gets, if somebody tries to change some little thing down here, the hash won't match up anymore, and you'll know about it. So there's a lot of redundancy checks built into Git. In any case, all of its files are stored here. There's basically nothing much in here right now, but as we make commits, we'll see that files appear inside of here that contain the commits. Okay, so you can think of it as like there's a hidden backup of your work in a subdirectory called .git, except it's not just one backup, but it'll be a large number of backups at various points in time. And moreover, it could be keeping track of the sequence of steps that you're doing, that somebody else is doing, or 50 other people are doing, etc. And you can see exactly how they got merged and pulled apart. And because it's so incredibly popular, when you want to figure out how to do something, you just kind of type a sentence into Google, and you'll find a whole bunch of descriptions of how to do it. There's lots of graphical tools for working with Git, etc. Okay, so let's do the next step, which is to create our file gauss.sage. So this step is create a minimal file that has something about Gaussian numbers. So I'm just going to do that graphically. I'll call it gauss.sage. And let's see, Gaussian rational. Let me do that. Definite. So I'm just going to use some very, very minimal thing here for starters. X, Y. I want to make X and Y rationals. And I'll make it so at least they can print themselves out. I. Does that look reasonable for an incredibly minimal Gaussian rational class? Okay, so it's just a little bit of code. Just put it in there so we have something. Okay, so there we are. And now let's add it to our Git repository. You can make all kinds of files. If you don't explicitly say, hey, Git, start tracking this file, then it completely ignores the file. So it won't say that when you try to do a commit. So I'll say git add, just paste it in right here. Again, I could also use the terminal. And now I've added it. And then I'll do git status, and that will print out our current status. And it will say that there's one new file that we haven't yet saved to our repository, and there's some other random files that are hidden sitting around here. Okay, and now finally I'm going to commit it. That's going to ask me for a commit message, and so I'm going to use the terminal to do that commit. You can also give the commit message as a command line option using the -m flag, but instead I'll use the terminal. So I'll say new, give me a terminal, and make it really, 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 really big. And I'll do git commit -a-v. -a means commit every single file that has changed and that you're tracking. You can instead say git commit, don't give the -a flag, and just give a list of files that are being tracked by Git, and it will commit only the changes to those files and nothing else. You might be working on different things in different files and want to commit them separately. And then -v, this is what it'll do is when you run this command, it's going to pop up an editor. At the very top line, we'll be able to put in a commit message. And then below, just for reference, it'll show exactly what changes it's committing to the repositories. It'll show you what's changed from what's in the repository versus what's in your working files. And that's what the -v option gives you. It gives you a verbose listing of what's changed. Okay, so I type that. Oh, look. It says, hey, wait a minute. I don't even know who you are. I don't want to go forward with doing the commit or anything else. Fortunately, it tells you exactly how to specify who you are. So what you do is just copy those two lines and fill in you@example.com and your name. So I'll do that. This is because I made a brand new project. Something you do exactly once, and it's project-wide. I'll do udub.edu. And you can put anything you want here. It's just kind of, each commit message will list who did the commit. And this is where that identity comes from. It's often fun when a project's evolved over time for a while to look at the commits and see how many commits each person made and then order them and see who's made the most changes or whatever, or additions. And when a project's been around for a long time and you're using revision control like this, like if it's been around for years, you can do fun things like there are automated tools that will draw like a picture and it'll show at the middle who's working on the project, and then as time evolves, that person will kind of disappear and other people will come in and kind of see things coming and going. It's pretty fun to get an overview of a project based on the people that are making the commits. Okay, so I've done that. Now I'll try again. Git commit -a-v. And now it throws me into this editor, the default editor in Pico. And it says that file is being committed. And if I scroll down, I can see what changes there are. So the changes are This is given as a diff. This is a standard way of describing the difference between two files. It says that no lines were deleted, and the pluses mean all of those lines were added to this new file. With Git, you can't add directories. You can only add files. But if a file's inside of a directory, then it adds kind of enough to get that directory. But that's a funny thing. OK, so I go to the top, and I enter a commit message. So initial version of the repo, say. Just starting. And then I hit Control X. The stuff that's below the commit line or commit paragraph, you can put some additional information. That just gets ignored, but it takes the first, everything before the comments, and it saves it. So I'll say yes. It saves it to some temporary file, and then it's used for the commit message. So if I do git log, we'll see that we now have one single commit. There is a SHA-1 hash. SHA-1 is a certain hash function. It takes a string as input or some sort of binary data as input, and it gives you a hexadecimal code that looks like this. And every single commit is referred to by the SHA-1 hash. You should think of it as being the SHA-1 hash of the exact state of everything at the moment when the commit was taken. So there it is. And there are a lot of different things that involve this commit, and you can specify this commit by giving the first few characters of the SHA-1 hash. And as long as it uniquely determines the commit, then you're good. By the way, I want to make a 2-minute philosophical aside. So in Git, the assertion that SHA-1 hashes don't collide is basically just made. You just assume that you're never going to have a SHA-1 hash collision, and then making that assumption, you build up this entire revision control system. If you're working and two SHA-1 hashes do collide, Git will just completely start, basically it'll completely destroy everything. You'll get wrong answers. It will be completely broken. As a mathematician, if you have that kind of perspective of, well, you can't write software that's clearly extremely buggy in the limit, then Git should be, in a sense, very disturbing to you. Like, literally, throughout the entire system, the way this thing is designed, if you made another commit that would end up with the same SHA-1 hash, it would just be this commit. Basically, Git would be completely broken by SHA-1 hash collisions. That is, if somehow two different things that the SHA-1 hash is being computed of were the same. Like if you had two files with the same SHA-1 hash, Git might just say, oh, I already know that file, and not actually record your changes properly. It's very different than some other revision control systems, like Mercurial. What Mercurial does, it actually records more or less the diff from one state to the next. Git, on the other hand, is completely different. It really literally is recording the complete state of all your files in a sort of deduplicated database where the data is really defined by its SHA-1 hash. And so Linus Torvalds, when he was designing this, he just said, let's just assume SHA-1 hashes aren't going to collide. And you do the back of the envelope calculation using, well, it's a little bit subtle because of the birthday paradox, but basically, because probably there's two people with the same birthday in this room, even though there's less than 365 people in this room. So you probably know about that because you're math majors. But in any case, the probability that two of these will kind of accidentally collide is extremely low. And it's less than, say, the probability of random bits in your computer getting flipped by cosmic radiation, which does actually happen, and not getting noticed. So you just kind of take the perspective that SHA-1 hash collisions aren't going to happen, and that they're very hard to fabricate. And then it's really interesting. Basically, a whole new world of how you can implement things that's vastly more efficient than what you can do otherwise pops up. And you end up being able to write something that's very eloquent and very fast in certain ways that would just be impossible to do otherwise. On the other hand, you have this sinking feeling that you know for a fact there are infinitely many ways in which Git could just give you completely wrong stuff. It's just highly unlikely. Okay? Disturbing? Disturbed? Be disturbed by Git, but on the other hand, just live probabilistically. It's very hard for me being a number theorist because it's just so a pure mathematician, so far from the way I like to think. But it works really well with computers. This idea that you make the assumption that low probability events won't happen, and then suddenly the potential for this sort of algorithms you can use and what they can accomplish is dramatically better. So it's just the world we live in. I strongly encourage you to read, for example, the give a link to it at the top. The Git book right here, there's a link to it. It has a really good discussion of the underlying data model that Git uses. Just basically under Git, I think it's under Git Basics, but it's right near the beginning. Just describes abstractly how Git is storing its information. And you'll realize that it is really a probabilistic way of storing things, which leads to the ability to do very cool things, but you're kind of, there's a low probability that it's all going to blow up in your face. Okay. All right, fixed issues with identity. We've made our commit. Just for fun, let's make one more commit. So I'm going to go over to my file. And what should I add? Nobody said a word today, so you have to answer this question. What should I add to this? Add, okay. That's a pun, but it's okay. Add self, right. I'm not going to do type checking yet. Gaussian rational, let's see, what is it? Self.x plus right.x, self.y plus right.y. Excellent. Okay, so I've added something. I can go over here and type git diff, and that tells me what's changed. Oh, that's awesome. I'm happy because I see that it's in color by default. Until recently, I had to do git diff space dash dash color, but I upgraded everything to Ubuntu, and apparently that's now the default with Git. So that's in color, which makes it easier to look at. And notice what it says is that the line, that red line right there actually got replaced by all of this. It's kind of funny because we didn't actually change it, but that's the way it happens to work. Note that with Git, what it does is it looks at your file and decides how things have changed on a line-by-line basis. This works really well for code in a programming language like Python, especially Python, where very often different things are in different lines. And this is really bad if you want to put an XL file, like an XLSX file, under revision control using Git, because basically it's just one long line. And so what'll happen unless you convert it to like an XML format, when you make one character change to your Excel file, it's just going to say replace that line by another line, which is basically replace the entire file. So Git doesn't work for recording, or it will work fine, but it won't be very useful. And it'll feel kind of bad to use for files like Excel files or Word documents or these or images. But it works very well for programs. It's for LaTeX documents, it depends how you use LaTeX. So if you're editing with LaTeX, you can use lots of separate lines, or you can have like every paragraph's one very long line, which some people do. And then Git is not very useful because you change one word in a paragraph, and it just like replace that entire paragraph by this other one. And that makes merges difficult when you have two different people working. So if you have multiple people working on certain types of documents where they can put new lines in, and you're using Git, you'd want to strongly encourage them to actually put new lines in. And this is, of course, in the context when you're editing in different environments. And obviously, if you're editing the same file online at the same time using synchronization, then it's not an issue. But, oh, and by the way, another thing, the way the real-time synchronization works in Google Docs, SageMathCloud, etc., one of the core ideas that Neil Fraser implemented, which is used by SageMathCloud and Google Docs and so on, is that instead of doing the diffs line by line, he rewrote things so you could do the diffs basically character by character. So you view the document as just one single long string, and you do all the diffing that way. But that's not the way Git works. That's the way the real-time synchronized document editors that you are probably hopefully using a lot work. Okay, so that's the change, and we'll do git commit -a-v add method. Okay, and now if we type git log, let's see the log. We've now added 2 commits. And there we are. And there's a new SHA-1 hash at the top, and there's one at the bottom. And now you can do all kinds of things. Let's see what I have in the thing. Let's see. So we committed it. So you can do things like git show, and then give the first few characters of a commit, and it'll show you what that commit involved. Basically, it shows you the files that were changed, the patches that were made to those files. So I said git show on the first commit that we made, and it showed me this. And you could say git show on the next commit, and it will show you that. Git show 5100D. Just give the first few characters enough to disambiguate. And that's the second commit that we did. Okay? By the way, just for fun, I'm going to quickly look at Sage itself. User local Sage current right here. I can do git log. The Git repository that you're using is just defined. Basically, when you do a git command, it keeps looking up at higher and higher directories. And when it finds in that chain of directories a .git file directory, then it decides that's the Git repository you're inside of. And so user local Sage current, that's the Git repository for Sage 6.2. And so if I type git log in this directory, it will show me the log for Sage, which there it is. So you can see there's commit messages for Sage itself. And if you do, for example, I don't know, git show on one of these, you'll see a diff that describes changes to the Sage source code, which apparently, oh, this is, I don't see any changes. Maybe there wasn't. Not sure why there's nothing there, but. And I guess just for fun, let's see, git log. Let's get just the lines that contain the word author, and then put that into word count -L to see how many lines contain the word author. So remember, this is just some command line foo. I'm taking the output of the entire git log. It should be absolutely enormous with probably like 15 or 20,000 commits at least. Actually 26,000 commits. And then grep gives me only the lines that contain the word author. And then I do a new thing, and then I take all that and pipe it into word count -L to give me the number of lines. So you can see there are about 26,000 commits to the Sage library over time. Okay, now let's move back to our Gauss project. And let's see, the next thing is make some changes and throw them away. So let's do something really stupid to gauss.sage. So we are drunk and we're trying to code, and it's not working out very well for us. And we do that, and then there's a bug, and some sync gets messed up, and I don't know, it just gets all messed up badly. Okay. So we've completely messed it up, and then of course we close it, and then we open it, hoping it'll magically appear in the right way, but of course it doesn't, and all our undo buffer is gone. And now we're like, oh no, what do we do? Okay, so I'm gonna get back the version of the file that we last checked in. Okay, so I'll do that as follows. I say git checkout, and I give the file name, gauss.sage. So what that does is it takes the current branch, we'll talk about branches later. In other words, the last place where you check this in, and then it checks it out. And what that does is it just copies it out of the .git directory, more or less, and puts it in the current directory. Okay, so it does that, and just like with anything on the command line, if it worked, it will silently return with no error codes or anything. Now if we look at our file, it still looks messed up, but the way the editor in here works, it's not actually, so if we sort of kick it a little so that it starts syncing, it should actually, let me look at the file to make sure that we got it correctly. Okay. Okay, so it's changed there. Oh, there it is. Okay, so what it's supposed to do is every 5 seconds, basically if the file that you're editing changes on disk, then it will get changed in the editor correspondingly. So when you check it out, it gets changed on disk, and then you see it change here. Currently, the way this is implemented, it just checks every 5 seconds to see if the file has changed. That is not the best way to do it. It really should use something called iNotify, which is an operating system thing that the moment it changes, it immediately notifies something, which will make this change. I implemented that, but it didn't seem to work quite right, so I decided to just turn it off temporarily. In any case, we're back. We haven't lost our work. And you can say git checkout and specify a particular version in the past as well. Let's say instead of looking at this version, we want the previous version. So in the git log, let's say we do, I think we can do git checkout, and then you give the commit and then gauss.sage. Now if we look at gauss.sage, it's the version before, okay? So you can actually check out any particular version of any file at any point in time. And you can also do things like git log and give a file name and just get the commit messages for that particular file. And you can also say git checkout and just give the hash and get all of your files to be reverted to the exact state they were at a particular commit. And there's of course things like git bisect, where if you regularly commit, when things are working and suddenly things are broken in some weird way, or you suddenly notice something's broken, you wonder when did it get broken, you can have it automatically go through and basically go back in time to halfway from where you knew it worked and test things. And then if it works there, you can go halfway again until you figure out exactly what commit caused the trouble. So there's really cool automated tools that are built around the process of recording your code in a revision control system like this. Okay, so we actually probably want the newest version. There's a shortcut. You can use the word head in all caps. That refers to the last commit, the one at the very top. Okay, so now our file should be, well, at least within 5 seconds, it should turn to have that tab method again. Okay, and it did. All right, so there's that. So I've showed you how to check out an early version. All right, so now we're going to use GitHub to make our project publicly available to the world. All right, so what I'm going to do is create a brand new GitHub account from scratch. And then I'm going to create a project called Gauss in that GitHub account, or for that GitHub account. And I'm going to push our repository there and set up SSH keys. Okay? And if you don't like GitHub, then things are incredibly similar if you use Bitbucket or something else. But GitHub is the most popular, and it's extremely polished. It's pretty neat. All right, so let's do it. I'm already logged in probably to GitHub in this browser, so I'm going to use another browser to separate my identity. So here I am at github.com. And this is a popular site for hosting Git repositories. And so let's see, I'm going to create an account. So let's see, my username, I want to be, okay, how about Math 480B Sage course. Gosh, I'm probably going to forget things instantly. Okay, wstein@uw.edu, invalid or already taken. There's a trick you can often use is with many sites, if you take your email address and right before the @ sign, I can see that this is very small. I see squinting, so I'll make this bigger. If right before the, and I'm going to forget this name, but it doesn't matter. All you need to do is remember this. If right before the @ sign you put plus and something else, then for quite a few services, they'll let you register that, and it's a completely separate account. It views it as a separate email address, but for the purposes of password reset and authentication and stuff, it's still the same email address. So if you take, like, your friend, if you send me an email at wstein plus whatever you want at uw.edu, it still goes to me. So did anyone here know that? So most of you didn't know that. This is very useful. Let's say you wanted to have 3 Dropbox accounts, all connected to your uw.edu account. All you have to do is do your name plus, and then give anything random you want.
You can also use it to like filter out spam. So if you want to sign up for something, you use that, and then if they start sending you spam, you just filter all that out.
Yeah, you can tell that they're sending it to that address rather than yours. So it's really, really useful. Not all sites will allow this. Some will just canonicalize it away, but you can see that it's really nice. Just a good trick to know about if you don't know about it. And let's make up a stupid password. XY38RTB. Made that up at random. XY38RTB4. Okay, there's a checkbox. Okay. 7 characters. Did you get it? Yep. All right, sign up for GitHub. Save my stupid password that everyone in the world knows. Okay, so now we have a GitHub account, and our next step is to pay them lots of money. Nope. Okay, so what we'll do is make a new project, and I guess finish sign up. And now make a new, actually it's called a repository, not a project apparently. New repository. I'll call it my repository Gauss. One nice thing is that the URLs into GitHub are incredibly easy to remember and figure out. It's basically just github.com/your account name, which in this case is Math4ADB Sage course, / the name of the repository. So there's no like funny codes or anything. Demo of using GitHub. And we'll make it public. I think for private you have to pay. And then we won't initialize it with anything. And we just click the Create Repository button. And now we will have a new repository. And now we will have a new repository. Don't know. Okay, now we have a new repository. So, important. I think that there's kind of 2 ways. So, there are 2 possibilities when you create a repository in GitHub, and fortunately it tells you exactly what to do in each case. One is that you're starting from scratch. You haven't made a Git repository somewhere else already. 2, you already made a Git repository and you now just want it to appear to be hosted on GitHub. Okay, those are the 2 possibilities, right? We've already made a Git repository, so we're in this situation. And it gives you exactly what you want to copy and paste to make it so that the code we just wrote appears on GitHub. Okay? So I'm just going to literally take what's at the bottom, right here. If I were starting from scratch, it basically just tells you kind of, here's what we suggest you do. But we've already done it. So the first line, git remote add origin, and then it gives a URL. What that will do is make it so that the repository that we have in our new SageMathCloud project views the GitHub repository as the remote one. So it's the default when you do things like git pull, git push, etc. Otherwise, you have to explicitly specify this every time. And then the second thing, git push, what that will do is it'll take our local repository and push everything we've done to GitHub so that everyone else in the world can look at it. Okay? Now, I'm not going to give exactly this line because I don't want to. I like to use the SSH URL. It's better because when you set up SSH keys, using that as your remote repository, you can set up SSH keys and then push and pull without having to type a password constantly. If you use the HTTP the name of the remote repository, then every single time you push, you have to type in your login and password, and that can just get really annoying. So I don't want to do that, especially because I like to push frequently. So I'm going to instead use the SSH URL. Until we set up SSH keys, though, it'll still ask us for authentication information. So we'll do git remote add origin and give this, oh, it actually changed it down here, which is kind of nice. So this is what we have to do right here. Copy, go over here, paste. Boom. Yes. And, we need to set up SSH keys, otherwise it's not going to let me push my code to the remote repository. Okay? So now I'm going to show you step by step how to set up SSH keys so that without having to type a password constantly, you can push and pull code between your SageMathCloud project and the GitHub project. The steps are the following. You type one command to create an SSH private and public key. You then copy the public key into a place in GitHub, and then you're done. So it's like 2 steps. It's pretty straightforward. And it's also, and the instructions over here, here's the command, ssh-keygen. So I type that one command, and it generates a public-private RSA key pair. And I'll just take the defaults. The private key is stored as a file in the .ssh directory in this project. You can encrypt the private key if you want, which I strongly encourage you to do. However, it gets a little tedious because you either have to set up SSH agent so that you don't have to constantly type in the password to the private key, or you have to constantly type in the password to the private key, which basically defeats the purpose. So, or at least makes it more difficult to use. But for now, I'm just going to enter no passphrase. So that means the private key is just going to be sitting there unencrypted. So anyone that has access to this project would then have access to that private key. Again, though, you can set a passphrase, and that at least encrypts your private key. And that's the right best practices to use in most cases. Okay, I never look at the fingerprint. What this means is it generated the default is an RSA 2048-bit key. So it generates a product of 2 primes such that the product has 2048 bits. So it's a big number. And in order to crack this crypto system, you'd have to factor that product of 2 primes. And nobody has ever announced, hey, I factored a random product of 2 primes that has that many bits. Like the record is around 700 or 800 bits, nowhere close to 2048. Okay, let's look at the files that this generated. They're in the .ssh directory right here. The reason I can see this, let me just remind you, is because I clicked on the little eye icon right here to show hidden files. If you don't see that directory, it's because you didn't click on this little icon in the top to toggle whether or not hidden files are shown. Similarly with, if you're doing this on your own laptop, the directories that start with dot are almost certainly hidden in OS 10 or whatever else, and so you similarly would have to do something to turn on hidden files. Okay, so we click there. There's a private key and a public key. The public key is right here. So this is some way of encoding an integer. I don't know if people here know RSA, but for people who do, this is encoding the public key for the RSA. So it's encoding the modulus and that 2048-bit number, and it's also encoding the encryption exponent, E. And that's the thing we're going to paste into GitHub. But while we're here, let's look at the private key, which is in this file. There it is. That's the private key. That has additional information that can only be known if you can factor, or if you, know the factorization of the 2048-bit number. Okay, so let's take the public key and copy it, and we're going to paste it into GitHub. So in GitHub, let's see, it's up in account settings. For a given account, you can add SSH keys. You can add a whole bunch of them. And I'm going to add just this one. So math 4ADB demo. And now here's the key. I just paste it in and I click add key. Okay, and now it says it's never been used. What that did was it gave GitHub, basically it said GitHub, anybody who knows the private key associated to the public key I just gave you, they're allowed to push code to this repository or do anything. They can delete everything. They have total control over the contents of this repository. It's not just that repository, it's every repository associated to this account. You can see why I made a new account for this purpose. If I had done everything I just did with my own personal account, any of you could, if you memorize the private key really quickly, could have somehow done bad things. Okay. Now if we go back here and everything works as it should, we'll see if it does. When I do git push, instead of complaining that we're not authenticated, it should just work. Okay? I don't know if it will because there's some time from when git says, hey, I have the key, until it actually works across their whole system. But let's see what happens. It just works. Woohoo! So what all that says is, hey, I pushed everything to the remote repository. And now, if we go back to GitHub and look at, I guess, our repositories, which are right here, and now look at the particular one for our course, or for our project, or for our example, there's a repository right there called Gauss. And inside there's one file called gauss.sage. And there's also several things you can do at the top. There's commits. If you click there, it gives you a graphical view of each commit. You can click on a given commit, and it tells you what happened in that commit. Anyone who's viewing this with a GitHub account can click on the little they can click on things like this and make comments about particular lines of code in the commit, which is pretty neat. You can view this as kind of like a whole project. There's a wiki associated with it by default, which lets you add all kinds of pages and stuff about this project. There's an issue tracker, so you could say, I want to make a new issue, add a subtraction method. I cannot type. Okay, looks like it auto-corrected. And you can say what sort of thing it is. It's an enhancement. And then you click Submit New Issue. It's actually pretty good. You can do things like drag and drop images to the little comment box, etc. And if we go back here, it'll show us all the issues we have so far, etc. So it's a really nice collaborative way to develop code and work on projects involving files. You can also edit the file directly here by clicking on Edit. Unfortunately, it makes the background black, which my informal polls have suggested 50% of you probably like, and 50% of you really hate. Actually, I'm curious about this class. I polled some classes. Do you like a black background? Okay, do you like a white background? Do you not care at all? Huh, okay. It's pretty evenly split between white and black, though. I don't know why. It's really weird, though. If you switch to full screen mode, it switches to the other color as the background. So somehow they've designed it so everybody will be unhappy. But then maybe people are so unhappy that they added this button, which I've never seen before. Cool. So you can now easily switch back and forth. But apparently it's only in full screen mode. Okay, so you can make changes directly here, and it will make new commits. Like let's add def sub self comma right. Let's see, minuses. And then I think I just go down here, and I can write add a subtraction method. Commit changes, and it just made a new commit directly in GitHub. So if we look at our list of commits, we now have 3 commits. The original one, we added our add method, and now we added a new commit, which is the subtract method. This change is, of course, not going to be in our SageMathCloud project. However, if we go over to our SageMathCloud project and look at it, of course, we don't have that subtract method, but you can say git pull, and it'll suddenly appear. However, nope, don't have enough time. I wanted to make do something that would involve a conflict, but I'll wait for that. So let's type git pull, and what it does is it pulls in the changes. If you say git log, you'll see them. There's now a subtraction method. If we look here, there it is. So you can see how 2 completely different websites are involved. The list of commits is there, and you can synchronize back and forth. So it's pretty powerful. Usable. Since it's 119, let's see. So we did this, push our repo, clone it. We haven't done these other things yet, but we'll start. Well, basically we'll start with this collaboration stuff next, where we have another person forking this project. And if you have a laptop on Friday, maybe you can bring it, and we can have like 20 or 30 people fork the project at once and see what happens. It might be amusing. Okay, so we're going to slam the heck out of this Git repo on Friday. Hello?
Hi, I have a question about reading.
Yes.
This person did not get the code into a vector.
Just
yeah.
there's some specific instructions that say to copy and paste it into such a
Yeah,
file.
but his code is not working, and I don't
Doesn't
know.
work? Okay.
Yeah, I don't know why.
It looks like it might be wrong. Let's see what line this is. It's in the plotting code. So the thing that's broken is the plotting and user plot errors. So I guess it's that dot plot function. When we look at the code for plot, then you write, here it is. I say that that's just wrong. That particular, yeah.
It's just a wrong
So
code.
I think everything worked except the line that has v1.plot. All the other stuff worked. Let's say you should just doc points for the plot command because it's wrong. Yep. I think you need a value. Yeah. But otherwise, it's just that one thing is wrong. Yes.
Professor, I was looking at the for my project. I'm thinking about doing the thing you recommended, the rotation of polygons.
Oh, cool.
Rotating.
Uh-huh.
I was looking at your
Nice.
I had looked at your code.
Mm-hmm.
So I went to manipulate it. I don't
The
know.
stuff that's built into Sage. Yeah.
This part, it keeps saying.
Cannot import name to MPL color. Let me think about it.
I submitted a color test, but well, you know.
I copied it all.
It's probably just somewhere in here. There's an import that's inside of the file that's relative to
I
directory
haven't
you're
really
running from.
changed any of your code. I'm just adding my own, and it hasn't really gone through. So I'm just curious, like how I can
Yeah,
start running.
this is yours, right? Nope, yeah, this is yours. So let me look. It's just easier to look at it with my. Okay, so the error is that it can't import to MPL color. So let's just see where that it's mentioned. Whoops, I just not meant to do. Find to MPL color. Okay, so you know, it's possible that this you copied. When did you copy this in?
I literally copied it like
So-
4 days ago.
Okay, because I did upgrade the version of Sage.
Okay, because I got it from
this
online.
last night. So,
Maybe that's
but you're using the old version, so that wouldn't matter. This, I mean, I'm guessing that this was like Sage plot this. So it may be that you copied it from the wrong, like a really old version of Sage or something.
okay.
Because these are the only methods, and 2MPL color is apparently not there anymore. So you might want to copy it from the current version of Sage.
Okay. And do you think I can just get that online?
Yeah, well, you can find it. There's a GitHub repo. So if you're browsing GitHub, under SageMath/Sage, and just source Sage plot. Do you remember what file it was in? I don't. Maybe just polygon. Okay. So notice that is actually it's in Sage plot colors now, but it used to be in Sage plot MISC. Here, I'll paste the URL for that exact thing here, so that you know about it.
Thank you so much.
Yep. So just start with that one.
Okay. Thank you.
Hey.
I emailed you. Did you get the thing about the bug in Sage or Sage worksheet?
What bug?
It
Which bug?
was-
When?
I had it. Interesting enough, I was on Sage, did my homework before, I think it was.
Mhm.
Then on